Problem number 18. A certain electric dipole is placed in a uniform electric field E vector of magnitude 50 Newton per Coulomb. The figure gives the potential energy U of the dipole versus the angle between E vector and the dipole moment P vector. The vertical axis scale is set by U of S, which is the potential energy, which is equal to 10 multiplied 10 to the power of minus 28 joule. Now we have to find what is the magnitude of dipole moment P vector. So here, let's we just go back to the theory, what we studied. When you place the dipole in the uniform electric field, what will happen? It will experience the torque, which is equal to P cross E, which is equal to PE sine theta, and also it will have the potential energy U, which is equal to minus of P vector dot E vector, which is equal to minus PE cosine theta. So here in this question, we are going to use this rule for getting the answer for dipole moment, because the question is related with the potential energy. Now we know the rule. So what is the rule? Potential energy, which is equal to minus PE cosine theta. And in the question, they give the value for electric field. The magnitude of the electric field here is 50 Newton per Coulomb. And also the potential value is mentioned here. And they said the value 100 multiply 10 to the power of minus 28 joule. Now the main thing, we have to find the angle from the diagram, because they clearly mention the given graph gives the information about the potential energy versus the angle. So you can see in x-axis we have the angle theta, in y-axis we have the potential energy, right? And you can see these, the value for the potential energy is given with respect to the angle by means of the curve. So now you can see this potential energy. Your potential energy, when it is here, it's greater at an angle of 0. So when theta equal to 0, your potential energy takes the maximum value, right? So here I can write this part as negative, because here I am taking the angle value 0 for negative of potential energy. So what I am going to do, so here for 0 angle, what is the potential energy? Negative. So from the graph I just write S. Now I am going to substitute the value, and the angle I consider the maximum angle here is 0 for this potential energy. So the theta value here is 0. So now I am going to substitute the value. So what is the value of potential energy? 100. So minus 100 multiplied 10 to the power of minus 28, which is equal to minus P, because we are going to find the value for dipole moment P, and the electric field is 50. So multiply by 50 multiplied by cosine of theta is 0. So cosine of 0 becomes 1. So what is remaining? So we can cancel negative both left hand side and right hand side, and cosine of 0 becomes 1. So this term multiplied by any number will be the same number. So what we have, 100 multiplied 10 to the power of minus 28, which is equal to P multiplied by 50 multiplied by 1. So therefore P, which is equal to 100 multiplied 10 to the power of minus 28 over 50. So we can cancel 0, and also here we can see we can cancel this 2. So what is the answer here? The dipole moment P, which is equal to 2 multiply 10 to the power of minus 28. And what's the unit for dipole moment? Because the formula for dipole moment is nothing but the charge multiplied by distance. The unit for charge is coulomb, and the unit for distance is meter. So coulomb meter is the unit for this question. So this is the answer. Thank you.